This video covers page 4 of your lecture note handout for section 3.7 on polynomial inequalities. In this video, we do our third example in solving polynomial inequalities. And in this video, we're going to do x plus 6 squared times x plus 2 times x minus 1 is greater than 0. We're going to find all the real numbers that we can put in for x on the left-hand side, and the value of the left-hand side will be strictly greater than 0. So in the previous examples, we got to find the values of x that make the left-hand side equal to 0. So we set the left-hand side equal to 0, apply the zero product property, and we find the real zeros of the factored polynomial up here are x equals minus 6, x equals minus 2, and x equals 1. Right? Those are the three numbers we can put in for x up here, and the left-hand side will equal 0. We then use those three numbers, minus 6, minus 2, and 1, to divide up the real number line into intervals. And so you can see I've plotted minus 6, minus 2, and 1 here on the real number line. And because these three numbers make make the left-hand side up here equal to 0 and not strictly greater than 0, we have open circles plotted at those three numbers. We then apply the test point method to the four intervals created by those three numbers. The first interval goes from minus infinity to minus 6, the second one from minus 6 to minus 2, the third interval from minus 2 to 1, and the fourth interval from 1 to infinity. So in the first interval, from minus infinity to minus 6, I use minus 7 as a test point. I put minus 7 in for x in our factored polynomial here, and the value of the polynomial is 40. That's a positive number. So that tells me any real number less than minus 6 put in for x up here will result in a positive value, a positive number for the value of the polynomial. In the second interval, I use minus 5 as a test point. When I put minus 5 in for x up here, the value of the polynomial is 18. And so again, that that tells me if I put any real number between minus 6 and minus 2 in for x up here, the value of the polynomial will be positive. It will be a positive number. In the third interval, I use 0 as my test point. And when I put 0 in for x up here, the value of the polynomial was minus 72. That's a negative number, a negative value, and so that tells me any number that I put in for x up here greater than minus 2 and less than 1 will result in a negative value for the polynomial. And then lastly, in the fourth interval, from 1 to infinity, I use 2 as my test point, and when I put 2 in for x up here, I got a positive value for the polynomial, and so that tells me if I put any number greater than 1 in for x up here, that will result in a positive value, a positive number for the value of the polynomial. And so we can't lose sight of what our inequality symbol is. We are looking for all the value, for the numbers we can put in for x that make the left-hand side strictly greater than 0. And so in our table down below, right, we can see the first two intervals make the left-hand side up above strictly greater than 0, and the fourth interval makes our value of our factored polynomial strictly greater than 0. So I have graphed the solution to this problem in step 4, and so all the real numbers less than minus 6 are shaded in. All the real numbers strictly greater than minus 6 and strictly less than minus 2 are shaded in, and all the real numbers strictly greater than 1 are shaded in. So we see the values of the polynomial are greater than 0. We see the values of the polynomial are greater than 0 or positive if x is strictly less than negative 6, or if x is greater than negative 6 and less than negative 2, or if x is strictly greater than 1. And so in interval notation, right? In interval notation, the solution is minus infinity to minus 6 parentheses, union minus 6 to minus 2, parentheses, union 1 to infinity, parentheses.